All right, so we've gone over how to find volume of a cylinder. We've gone over how to find volume of a cone. So now we're going to talk about how would you find the volume inside of a sphere? How do you find the space inside of a sphere? Now, normally in class, we would go through how a sphere relates to a cone, and then how they came up with it, how they changed. You take the volume of a cone, which is pi r squared divided by 3, so 1/3 pi r squared times the height, and then they adjusted that for a sphere. So I'll go through it real quick. Normally, I would have you all kind of figure things out, figure it out on your own, but I'm going to give it to you a little easier since we're doing a video and just kind of walk you through it. So normally they would look at this and they would say, well, a sphere doesn't have a height. All right, so when you're looking at a sphere, when you look at a basketball, it doesn't have a height. There's no height in a sphere. So they took this formula and they're like, well, we need to get rid of the height. So instead of the height, a sphere has a diameter. So the height on a basketball or a sphere is really just the diameter. So we wouldn't want a formula that has radius and diameter in it. That would make it too complicated. There's an easier way to do it. So they said, well, technically then the diameter is just the radius twice. So they took out the h and replaced it with 2r for 2 times the radius. So they took out the h, put 2r there. Then they simplified it, and they said, well, if I have an r squared and an r, then together that's really 3 of them. So r to the 3rd power. They took the 2 and put it out to the front. And then they said, okay, well, how does the space compare? So they said, well, just like we did with the cone and the cylinder, and we found out that 3 cones full of water fill up 1 cylinder. So it takes 3 cones to fill up a cylinder. Well, let's do the same thing with cones in a sphere. How many cones does it take to fill up a sphere? Well, if we did that same experiment, but took a cone, filled it up with water, poured it into a sphere, it would take 2 cones to fill up a sphere. So then you would take this and multiply it by 2. So they just did 2 times that 2. And then that's how they got the formula. So the formula for a sphere is just 4/3 times pi times r to the 3rd power. So sphere is actually the easiest one because you don't have to substitute in 2 numbers. All you got to do is find the radius, and that's it. So if we go and look at an example, we've got volume of a sphere, 4/3, 4/3, pi r cubed. So all you really got to do is look at it and say, okay, here's your sphere. What is the radius? Because that's the only number we have to substitute in for. So halfway across the circle is 2. So the radius is 2. So all we have to do is put a 2 where the r is. So if we go to write this out, we've got 4/3 times pi, which is 3.14, times the radius, which is 2, and then you just got to remember that it's going to be to the 3rd power, and that's it. Put that in the calculator, and it's done. So easiest way I tell people to put this in the calculator is for 4/3, I say type in 4 divided by 3. So 4/3, it depends on the calculator you have. If you have a calculator that can put fractions in, you can put 4/3 in. If not, put 4 divided by 3. So 4 divided by 3 times 3.14, and then times 2 to the 3rd power. So depending on what kind of calculator you're using, you got to make sure you go 2 to the 3rd power. If you don't have a calculator that lets you put exponents in, you could always just type in times, and then whatever this number is, 2 times 2 times 2. because it's 2 to the third power. So 2 times 2 times 2. All right, whichever way works out easier for you. Mr. Candy's room. Hey, I'm doing a Google Meet, not Google Meet, but my video notes right now. So can I call you back in a minute? Okay, thanks. Sorry about that. I had a phone call, so I had to take care of that. All right, so we got 4 divided by 3 times 3.14 times 2 raised to the third power, and that gives us 33.49. If I pull up Desmos and we look at that, let's say you can't figure it out, you're not getting it to work on any other calculators. Well, we use Desmos in class, so we've gone over how to use this. So let's say, all right, there we go. Let's say we wanted to use this to put it in there. So we had 4/3. So we just do 4 divided by 3, so 4/3, and then go over, and then times 3.14 times 3.14, and then times, and we've got the radius to the third power, so 2 to the third power, so 2 raised 2, so you hit this button so that you can make the exponent whatever you wanted. And then there you go. So Desmos is pretty easy. And then a little secret for you, since you already got this typed in, shortcut, make it a lot faster. For each problem, since all of this stays the same, all you really got to do is click right here and just change that number. So if the radius of the sphere is 8, put an 8 there. There's your answer. If the radius of the sphere was 2, put a 2 there. There's your answer. And then you can go through the problems real quick. Let's say the sphere had a radius of 10, put a 10 there. So, once you have that part typed in, the 4/3 doesn't change. The times 3.14 doesn't change. The exponent being a 3 doesn't change. The only thing that ever changes is that right there, the number that is the radius of your sphere. So you might want to use Desmos, make your work a little easier. So if we take a look at our next one, we've got this model of the Earth has a radius of 6 inches. Calculate the volume. So we need 4/3 times pi 3.14 times the radius to the third power, which the radius is 6. So 6 to the third power. Hopefully everybody wrote the formula down, so you've got that. So you'll be able to go through these assignments real quick, real easy. You can use the formulas on the quiz. You can use the formulas on the test. So like I said before, we want to figure this out. If we go back to our Desmos calculator, 4/3 times pi times the radius is 6, so we can put a 6 there. And then that's all you got to do. All right, got another phone call. So let me answer this, and I'll get back to y'all. Mr. Candy? I'm in the middle of making my video notes. Sure. All right. All right. So we got 4 divided by 3 times 3.14 times 6 to the third power gives us 904.32. Let me mark down who all I'm supposed to call before I forget after I'm done making these notes. All right, so just like real class, we got the phone ringing off the hook. All right, I didn't mean to do that, so I'll have to type that back in a second. All right, here we go. Go to the next one. They got me thrown off a little bit. All right, so the radius of an NBA regulation basketball is 4.8 inches. What is the volume of the basketball? So you do this one and see if you come up with the same answer I get. And then our video notes were pretty short because there's no reason to go through a lot of examples when they're all the exact same thing. 4/3 times pi times the radius to the third power. So you solve that, see what you get. So you should have paused the video. If you would have worked it out, you would have had 4/3 times pi, which is 3.14, and then times the radius to the third power. The radius is 4.8 to the third power. So when we go to your calculator and you type that in, you got 4/3 times 3.14 times the radius, which is 4.8 raised to the third power. 463, and then the 1 would tell the 0 to stay the same, so you just leave it 463 inches cubed. 463 inches cubed. All right, pretty simple. So let me find one that gives the diameter instead. All right, look at that, very next one. So the diameter of a baseball is 2.8 inches. Calculate the volume. So I need 4/3 pi r cubed, but they give us the diameter. They say all the way across the baseball is 2.8. The diameter is 2.8, but we only want halfway across. So we need half of 2.8. So 4/3 times 3.14 times 2.8 divided by 2. To find half of that, half of 2.8 is 1.4 to the third power. And then you could solve it. So volume of a sphere, pretty simple. Just find the radius, put into the formula. Make sure it's the radius. Make sure it's not the diameter. If it is the diameter like they just gave us, make sure you divide it by 2 so that you can figure out what the radius is. All right? If you have questions, come to the Google Meets, please. They're extra credit. I'm just there hanging out. We have one in the morning and one in the afternoon to make sure we have plenty of time for you to log in. Come say hi. Come ask questions. We can pull up the assignments and go through them together. All right, we need to make sure you know what you're doing. So if you have any questions, please let me know. Email me. Other than that, great job. And I'll go ahead and end this. So talk to you all later.